So I'm going to start with some homework questions from 2-6. And then transition into like more test review specific stuff. Sound good? Chanel?
Number 37.
37?
I figured it out. I don't know if my method was the same as yours though.
Okay.
Actually, get out of here at 5:11. I can't.
So one way you could think about it
That's what I thought.
and that goes to 0. That kind of oscillates between 0 and 1, but
So wait.
still just comes out to 0.
Yeah, that leads to another question about the law.
Now, okay.
Oh, go ahead.
Well, there's another way
Okay.
that you could have done this. Did anybody try this a different way? Squeeze theorem would have been a good option there, right? Because we know that
That's what
and if you multiply both sides by e to the negative 2x, we can do the, what are we going to, infinity? So I can say by the squeeze theorem, the limit as x approaches infinity of e to the negative 2x cosine x equals 0.
So I had a question on that law actually. The e to the, what is it? Like as x approaches infinity, e to the x is equal to 0. So can you say like 2 times x, like e, like as x approaches negative infinity, e to the 2 times x is
Sure.
0?
Yeah.
How unlimited is it? Can you also say negative e to the negative?
Yep.
Okay. What can you not say?
Well, if this was negative infinity, now all of a sudden that exponent becomes positive infinity,
Okay.
and that's a problem.
Okay.
But I don't know. I think otherwise it's fine. Doesn't matter positive or negative. Because it's going to 0, right?
Okay.
Katie? Of course.
Oh, is that all you have to show?
For the squeeze theorem?
Yeah.
Well, we got the inequality, right?
Yeah.
So all we have to do is the limit of the left side and the limit of the right side. And then we can quote the squeeze theorem saying that the middle has got to be the same thing. Is that?
Yeah.
Sure. Get those circles out of there. Is that okay, Chanel?
Yes, thank you.
Sure. And the reason why this is okay is because yuck. This is it's the same thing. Yeah. My throat just like spasmed or something. It was very weird.
It just happened to me 2 days ago.
But this is the same thing as an exponent of an exponent, right?
Okay.
So if I stick a limit here, I can move the limit inside, and then I just have like 0 to the k, which is 0.
So, but it can't work if you have like x approaching like a certain value, it can only be to infinity?
Correct, yeah. If that's going to a specific value, then it's a direct substitution situation,
Okay.
right?
And then, so it would also be the same thing if, like, for example, you're multiplying by -1, this whole thing, that's why you could say it's negative e to the k at.
Well, I have the -1 from here,
Yeah.
from the bounds of my building my squeeze theorem out.
So you could say like negative, and then in parentheses e to the -2x is 0, and -1 times 0 is 0.
Oh yeah. Yes. Yeah, I misunderstood what you're asking, but yes, 100%.
Okay.
More 2-6 stuff. Audrey, 19, sure. Drop that one in there. So I would do this. If I did a direct substitution, basically I have like infinity over infinity, right? Which is one of those indeterminate forms. So I can't deal with that. I'm going to multiply by 1 over t squared. Why 1 over t squared, not 1 over t or 1 over square root of t? Why t squared?
It's where you could rewrite it as t to the
Then it won't be
the
indeterminate.
denominator will be 0.
So I wanted the biggest exponent of t that doesn't give me a 0 denominator when I applied the limit, right? Yeah, yep. I just wanted to ask before, and like these, what are you looking at questions, you know, like I think that's important. Now, I'm going to think about the square root of t as t to the 1/2. So that's going to be like the same as 1 over t to the 1.5.
Wait, where'd you get the 1.5 from?
1/2 minus, like I have,
Oh, my.
The square root of t times the 1 over t squared.
Oh, got it. You subtracted t to the 1/2. Like,
so just,
Because
yeah,
I got like the square root of like t over t to the 4, and then you cross it out and you get like the square root of like 1 over t to the yeah, t cubed. And then it's like somehow.
yeah, that's like, okay, so this is the same thing as like 1 over like t root t. Is that what you're saying that you ended up with?
Well, I ended up with like.
Or 1 over square root of t cubed? Yeah, that's the same thing.
Okay, and then 1 over like t to the 3/2.
Yep.
Okay.
3/2 is the same as 1.5, right? I just, why deal with fractions if I don't have to, right?
Yeah.
You know, like, but yes, still, same thing. Great. And now I apply my limit laws. So this goes to 0. Does it matter that it's a fractional exponent? No way, Jose. Because our limit law for 2-6 that I'm applying works for any rational number r. So 1.5 is definitely rational, or 3/2, or however you want to write it. So I can definitely just send it right to 0. Good. I like it when you guys get the right answers. Makes me feel like I'm doing a decent job. Or you guys are figuring out in spite of me. One or the other. Hopefully it's the first one, less of the second one. What else? Who's next? Any more 2.6 stuff that we want to talk about? Well, I want to talk about 62 because I saw a lot of people skipping it. Can we talk about 62?
Well, question like 62 appear on the test.
No. But here's the bad part, though. We have like a whole section on like how do we do calculus with story problems like this. That happens in, I think it's section 3.9.
That's a while now.
Well, this is we're nearing the end of chapter 2. So it is a little while from now, but it's not as far as you think. All right, so it says the tank contains 5,000 liters of pure water. Brine contains 30 grams of salt per liter of water is pumped into the tank at a rate of 25 liters per minute. Show that the concentration of salt after t minutes in grams per liter is yada, yada, yada. And then part B, what happens to the concentration as t goes to infinity? Okay, well, here's my tank. Here's my 5,000 liters. Here's my tap. Bloop. That's a terrible drop, Mr. Kulik. I know. One note's hard to draw. That one's a little better. And what's coming out here, I have the rate is 25 liters per minute. And my concentration is 30 grams per liter. Everybody's okay with that? So that's what's coming in. Everyone knows brine is just salt water, right?
Yeah.
Okay. So it says, show that the concentration of salt after t minutes in grams per liter. Chemistry people, what is grams per liter?
Volume, density,
No, man.
either. It's always
It's like
molarity,
not molarity,
molar volume.
molality
Oh, we didn't
is
know that.
grams per liter. AP Chemers? You know,
Molality?
yeah.
We now learn molality.
Molarity is moles per liter.
Yeah.
Molality is, oh,
Such a tongue twister.
yeah. Okay. So we're going to have, volume of liquid on bottom and grams of salt on top, right? Now, what makes this tricky is that at every instant, you're getting more salt water in the tank, right? Everybody agree? So the concentration is changing at every instant, as well as the volume of liquid in the tank, right? Because we're dumping more liquid in. Everybody agree? Okay, so after 1 minute, how much liquid would be in the tank? $5,025, right? Because we're adding 25 liters per minute. After 2 minutes, how much would be in there?
5,050,
3 minutes?
5,075,
Okay, so T minutes.
5,100. Oh,
25 T.
Plus
25.
5,000. Okay. After 1 minute, how much salt is in there? 30 grams. After 2 minutes. Oh, I'm sorry. No. 1 minute. No. After 1 minute, how much salt is in there? 30 times 25. There's 30 grams of salt per liter, 25 liters went in the first minute, right? 30 times 25. Yes? Everybody's okay? After 2 minutes,
30 times 25 times 2.
30 times 25 times 2. After T minutes, 30 times 25 times T. Yes, good. Everybody agree? If I look at that denominator, I can factor out a factor of 25. And that's what I wanted, right? The problem asked to show that. There's my show. So that's part A. Part B asks for the limit then as x approaches infinity of this.
You can plug it down here.
I mean, you could. I would just do like,
Or you could do that.
right? So it gives me oops, forgot my limit. Now, does that make sense? Imagine you have a cup of water, no salt in it, right? You dump the entire ocean into that cup of water. What's going to be the concentration in your vessel?
Very simple.
The same as the ocean was, right? Because that cup of water at the end of the day doesn't really matter because you have the entire ocean filling it up and offsetting it. What's the concentration in the ocean that we're adding in here? 30 grams per liter. Eventually, the whole thing is just 30 grams per liter, which makes sense, right? I love it when reality matches up with the mathematics, where I could just like think it through without having to do the algebra or the, the calculus in this case, because we have a limit. But that's cool. Aren't you excited to see like a whole chapter of doing problems like this, where you do calculus on this kind of a setup?
Kind of scared. More excited.
It's okay. You can be scared right now. You save your excitement until we get there. Other 2.6 stuff though before we transition. Okay. So while people were finishing the study guide, Chanel started to ask me like a really important question that I asked that we can just save until, so we could talk about it like as a group. So I'm going to ask her now to like repeat her question so we can all hear it. Because I think this is like what most of mathematics studying comes down to is this question.
Like if you're given like a limit, if like x approaches infinity or x approaches like a specific value, how do you know like where to start, like what method to start?
Right. This is what it comes down to mathematics, right? We've seen all these different kinds of problems. How to identify like what I should be doing with this problem, right? Most of us, if we know what to do, feel capable of doing it. The hardest part is like I have all these tools in my toolbox. How do I know which one to pull out to use, right? That's what it comes down to. That's often the hardest part. So let's say that we have the limit as x approaches a, where a is a finite value. What can we do here? Direct sum, right? That's something we can do. What do we need to have for this, though? Continuity near a, right? You don't need continuity everywhere. You just need it surrounding the value that we're plugging in. What else could we do? Table, graph. Okay. Or we might, what else?
Like you said algebraic. Well, the algebraically goes down to direct substitution too, because you can algebraically manipulate it. So you can do direct substitution.
So you might need to do some algebra before you can direct sub, yup. So what kind of, when we say algebraic, what could we do? Factor and reduce, yup. Multiply by the conjugate, yup.
Foil.
Could FOIL and cancel. I would say, what was it? Oh, common denominator. Usually that's paired with reducing, though. It might mean like, so that's kind of the gist of it, right? And these things, after we've done any one of these, you might feed back into a direct substitution or something, right? Does that feel okay? If we have a or limit at infinity, can we do direct substitution?
No.
No. How about tables and graphs? Are those still going to be okay? Sure, yeah. What's the drawback for each of those? Technology dependent, right?
Yeah.
Like if you have
It's on the notebook.
yeah, if you have like a weird piecewise function, like getting a graph out of that's not trivial to look at, like that could be difficult or time consuming anyways. Or it could just be like, you know, like an exponential times a trig times a logarithm. It's like even if like without a calculator, I have no clue what this is going to look like, right? Like what, I don't know, right? I wouldn't know. And then we still have algebraic, right? So can we still do these algebraic techniques from above?
No.
So, yeah.
Yeah, those are still on the table. Those still might be useful. Probably not, but maybe, right?
I was gonna say the 1 over x trick.
Yeah, so that's often, you know, let's just say, you know, oops, I meant Rx. It's an X in there, dumb. Ooh, you know what else what we didn't include here? Squeeze theorem on the table for both, right? I don't know, does this help in terms of like what to do when?
Yes.
You know, like these are good questions. Like for the most part, like individually, once you've narrowed it down to like, okay, which branch what should I be using? I can algebra my way through it. It's just like getting to like picking the right one out. So in terms of if I want to do I'm sorry, Katie?
What's like the best way to do it?
Yeah, that's
Good one. Yeah, sure. What if f of x is piecewise? Well, depends a little bit about like what the presentation of f of x is. If it's a graph, if I already have the graph of it, I'm going to just use like graph to do it, right? But if I'm given a piecewise equation, you know, like say f of x is equal to, you know, some g of x for x greater than 1. Let's do less than 1. And then maybe some h of x for 1 to 2. And then some j of x for x greater than 2. And let's just say for the sake of argument that G, H, and J are all continuous over their respective domains. Now, if I want to do the limit as x approaches a of f of x, what would I do here? I just do direct substitution unless f is what numbers? Or unless x, or I should say a is what numbers?
One of the ones in the function.
So specifically here for the function I've written,
One or two.
1 or 2.
Why can't it be 1 or 2?
Well, because those are the boundaries between the two pieces. What if it's a piece, what if it's a jump discontinuity there? I don't know that those are the limit from the left and limit from the right are going to be the same. I don't know the limit's going to exist, right? I can't do a direct substitution at the boundary of a piecewise. What do I have to do there instead? What would I do instead?
We have to prove that it's continuous at one or two.
I don't even really need to do that. I just need to do the left hand and right hand limits. And there I can direct substitute and see if they're the same.
If they're not, then that value doesn't exist.
And if it doesn't exist,
The limit doesn't-
if the limit doesn't exist, it doesn't exist. If they're equal, then that's the limit, and you're done, right? So you just have to pick the appropriate piece. You know, if it's 1, you know, this is the left-hand limit at 1, that's the right-hand limit at 1, so I'm plugging into G or I'm plugging into H, respectively. Katie, is this kind of what you're looking for
Yeah.
when we talk through this kind of stuff?
What would you plug in?
So let's be specific then. Like, let's say we're doing the limit as x approaches 1 of f of x, right? So the limit as x approaches 1 from the left of f of x is just going to be the limit of x approaches 1 of g of x.
Oh, okay, you just use that.
And then I can just direct substitute because it's continuous. And then the other one is from the right, I have h of f, or f of f of f of x is just the limit as x approaches 1 of h of x, which is just going to be h of 1, right? Just doing a direct substitution. Chanel?
Can you give an example of like this piecewise function thing? Because I don't think I'm getting it. Like the thing that you just said, but give g of x and h of x like a value.
I mean, like, I don't know, it doesn't have to be anything fancy. Just be x squared, x cubed.
So are you like looking? So for this example, are you like looking for the limit of this?
So the question was, what do I do if I want to do the limit as x approaches 1 of f of x? 1 is one of our boundary points between the pieces. So there I can't just direct substitute into f because I don't know that the left hand and right hand limits at 1 are going to line up
Oh, is
to
this
be
like,
the same spot.
Is this like number 11 and 2.2?
Believe it or not, I don't have the problems memorized like that, but quite possibly.
Okay.
That's very specific, but quite possibly. But yeah, all I'm doing is I'm checking the left hand limit and the right hand limit.
Okay.
You know, in the case of if it's x and x squared, at 1 they are the same, right?
Yeah.
When I plug 1 into x, I plug in 1 into x squared. It's the same thing.
So, okay, so you're just direct substituting. Well, wait. So you're not direct substituting a value at the boundary point because there could be a discontinuity.
I'm not direct substituting into f. I'm direct substituting into each of the pieces to get the left hand limit and the right hand limit for f.
Okay.
Right? Like, you know, say this is our graph of y equals f of x. And say like, here's g, Here's h. And then like, you know, here's j. I guess those guys were filled, right? So if I want the limit and say this is like x equals 1 here. So this is the limit as f of x approaches 1 from the left. But this would be the limit of f of x as x approaches 1 from the right.
They don't have, so the limit doesn't.
So the limit might not exist. If I just plugged in, direct substituted in, I'd get that value,
That's not true.
which is not what the limit is, because the limit here doesn't exist.
Okay.
So I have to look at the piece, the left-hand and right-hand limit of my piecewise function, if it's at a boundary point. If it's not at a boundary point and you have continuity, you should be fine.
Okay. So I'm sorry. So what did you suggest to do instead? Like instead of keeping the boundary point.
You do the left-hand and right-hand limit. This.
Oh.
Yes, go ahead. You're
So
welcome.
you just direct substitute the left-hand limit and direct substitute the right-hand limit?
Yeah.
Okay.
Yes. And see if they match.
Okay, and if they don't match, then the limit doesn't exist?
Yes.
Okay.
Yes.
Sorry.
That's okay. And then Katie, if this was infinite, this was like an infinite limit here for this piecewise. Is this still helpful, like what we're doing?
Yeah.
Okay. Like if it stops being helpful and it just becomes like this is now too abstract, like you holler at me and we can do better or whatever. But I'm trying to be like generally vague because this is a selecting method question, not a like what is the answer question. So if I wanted this, what do I do? Yeah, if this is the same f of x that we defined before up here, where it's g, h, and j, let's just start with minus then. Well, that's going to be the same as the piece that involves negative infinity, right? And now I can just use my techniques because we're just looking at g of x, one part, which is continuous over that part. So I just use like multiply by 1 over x or something, you know? If it was positive infinity, which piece of f of x would I take? J of x, because that contained all the stuff that was greater than 2 or whatever it was. And again, what would I do? Like whatever the technique is I need to do. Maybe I have to multiply by conjugate and then multiply by 1 over x or whatever, like just becomes a normal limit at infinity problem now. Does that,
Yeah.
Okay. Giselle.
If it's like 1 over x times x to the power of 2 or whatever.
1 over x times x squared.
Or like at the bottom. I'm just like saying like, you know how you said you have to like multiply by the highest power of the denominator when you're trying to
So
the limit going to infinity?
So we have so you're saying you have a problem like this.
Yeah. You can only go to the maximum of the power that you have, right? Because you don't want to cancel out the bottom and get indeterminate.
Yes, I would do this.
Okay. So
Because
just
that's
the
going to give me
maximum-
1 over x squared, 1 over x plus 1. And it becomes 0, 0 plus 1, 0.
Okay. So you can only multiply by the highest exponent that you have in the denominator. Or can you go
Yeah.
by, like, I can't, like, just like hypothetically, I couldn't multiply by 1 over x to the 4th if it was the highest power of the denominator was x to the second.
I'm trying to, here's the thing, like, if you have a polynomial or something with like, or even just like rational exponents, I would say yes. If you have like other stuff in there, maybe you might want to, but I don't think you'd ever see a situation like that in a course like this.
Okay, good.
So I'm just trying to be careful because you're asking me like an always question. And as a mathematician, I'm always very suspicious to answer like, yes, always, because usually the answer is not always.
Okay.
And it's something I haven't thought deeply about, and I hesitate to answer that. But I think for the purposes of a class like this, 90, I can't think of a counterexample to it.
Okay, that's good then. Thank you.
Yeah, I'm not sure I can come up with one off the top of my head.
I was just like, sometimes I get confused on what to multiply the denominator by.
Mhm.
So I just wanted to ask.
Yeah.
Clarify.
Yeah, absolutely. No, and I want to give you that clarity.
Yeah.
I hesitate for a moment because I just don't want to like, it's a question I wasn't prepared to answer, and it's very like, always is like, oh, I got to think about all the possibilities here for a second.
Right.
But I think for, if you have something that's like polynomial-ish, then yes, is your answer.
Thank you.
You're welcome. Chanel?
Wait, I'm so sorry. Can you give an example of like infinity for like a piecewise function? Like if it's like
I mean, so if I'm doing to negative infinity, I'm just using this piece, right? So just do the limit as x approaches infinity of that piece. Or negative infinity for that piece. If I'm approaching, if x is approaching positive infinity, I just would use that piece.
okay.
So I just, whatever that piece is, I do it like a normal limit at infinity, just for whatever g of x is. And I ignore the other two parts.
And then if they line up the limit.
It doesn't, they won't, they don't need to line up because a limit at infinity doesn't require left-hand and right-hand limit because you can only approach infinity from one direction or the other, right? I can't approach negative infinity from the left because there's nothing on the left side of negative infinity. Negative infinity is as far left as you can go, so it only goes one direction. And the limit at positive infinity only can approach it from the right because there's nothing to the right side of, I'm sorry, you can only approach it from the left because there's nothing past positive infinity. You know what I mean? You can't have right-hand and left-hand limits at negative infinity or positive infinity because there's nothing past either one of them. It's like the end of the number line. Is that, you didn't like that? I can tell by your face you didn't like that. Ask again. We'll do it in a different way. So say you have this, right? Which one of these three pieces is the one that I care about? Which one of them is x approaching negative infinity with?
The top.
The top one. So this is just the limit as x approaches negative infinity of 1 over x squared,
Which is 0.
which is 0. Done.
Okay.
If I did the limit as x approaches positive infinity of f of x, which piece am I worrying about now?
The bottom one.
The bottom one. So limit as x approaches positive infinity of x cubed plus x squared over x squared plus 1. Giselle, what I multiplied the top and bottom by?
Okay, sorry. Jack.
That's okay.
Wait for the.
This one at the bottom. That guy right there. It's your question.
It's 1 over x to the.
Yes.
To 0 plus 1. Got you.
And if I do that, I'm going to end up with just infinity. Because I'll be left with an x on top and a constant on bottom.
And then, so for the middle one.
Doesn't matter.
like,
Because we don't care about it, because we have x approaching positive infinity or negative infinity.
oh.
The stuff in the middle
okay.
does not matter.
Oh, okay.
Does not matter.
Okay.
Only if it's a finite value could the stuff in the middle possibly matter.
Yeah, because you're looking for a specific point. Okay,
And
I'm so sorry.
and even like here, if I did the limit as x approaches 0 of f of x, what would I do for that?
You do that one, the middle one.
Yeah, I just do 0 plus 0 over 1 minus 0. I just direct substitute it.
I'm so sorry.
That's okay.
I,
Since it's not a boundary value, it doesn't matter. I just direct substitute in where I need it because I have continuity over all those intervals.
okay, and then so for the middle one, do you decide what to multiply? I think you were explaining to Giselle this, but like you decide what to multiply by the bottom is like as long as it doesn't make it infinity, like equal to 0. Is that how
Well, you're talking about this one here?
yeah, like when you're deciding like multiplying by 1 over x squared, like
Right.
stuff like that.
Usually it's going to be the biggest x in the denominator.
the biggest x in the denominator.
Usually.
Okay.
It's-
That's a good tip because I was like struggling with that one. So.
Sure, no problem. Is this, do you guys feel this is helpful, what we're doing? This is what you need? Okay. What else do you want to talk about? So that was like, how do I know what to do with a limit problem, right? Do we feel like we got all the things, the cases that we're like kind of confused about covered-ish? I know we didn't do very many specifics in there, but I feel like it wasn't a specifics question, it was like a generals question. So I tried to like keep it general. Yes, sir. General, sir. Get it, general and general. It's making an army joke. Who's next? What else should we talk about? Katie.
What about IVT? Is that like if it doesn't give you a interval?
Yeah, you know what's actually a nice example for the IVT? Do you remember, it was one of the AP questions that I gave you guys to do. Let me find it. I think it was level 1 part B, I think had a good IVT question. You want to look at that one? Just so we have something specific to look at? Okay. Anything you say, right? You guys are so agreeable some days. Let me grab that real quick. B. It takes so long for these student practice problems to like load in because it has the solver format on the side where you have to like fill in all the blanks. All right, here we go. All right. It says the number of books sold in print of a new nonfiction book can be modeled by a function n of t, given below, where t is the number of months since publication and h is a continuous function for 0 less than or equal to t less than or equal to 10. Selected value of h are given in the table. Must there be a time t for 0 less than or equal to t less than or equal to 10 when n of t is equal to 1,000? Justify your answer. So here we're asking, does a specific x value exist that gives us a certain y? This is exactly what the IVT is going to allow us to do, so that's going to be our tool. Okay? Whenever you're asked to like, is there an x that gives us like a certain y? That's exactly what we're looking, that's an IVT question, like textbook, how it'll, almost certainly how it'll look. To use the IVT, the first thing we have to have is continuity over the interval that we're looking on. So, is n of t continuous? Over its whole domain? I don't frickin' know. Do I care though?
No, at the interval, wait, where's h?
So, over 0 to t, or 0 to 10, n of t is just h of t.
Is h of t continuous?
What did it say in the problem?
Oh, okay.
Oh, okay.
So yes, I have everything I need. So on 0 to 10, h of t is continuous. Oops. And on 0 to 10, n of t equals h of t. So n of t is continuous on 0 to 10. Is everybody okay with the reasoning that we've given there? So far, so good. Now let's look at h of t. What y value am I interested in? 1,000. Do I see a place on h of t where the y coordinates would have to pass through 1,000?
Yeah.
Yes. Where does that happen?
Between 3 and 4.
Between 3 and 4, right? Where it goes from h of 3 is 780, and then h of 4 is 1340, and if we're continuous, we have to pass through 1,000 to get there, right? So I would say, since h of 3 equals 780, which is less than 1,000, which is less than h of 4, which let's say is less than 1340, which equals h of 4. The IVT states there exists a C on the interval from 3 to 4. Boy, my penmanship stinks today, guys. Such that n of C equals 1,000. Actually, we should probably say h of C equals 1,000. And since n of t equals h of t on, I'll just say 3 to 4, n of C also equals 1,000. Let's be specific. Yes, Nolan?
Do you have to put h of 3 equals 780? Or could you just put h of 3 or just put 780?
You could probably get away with either one. I'm just being specific so I don't have to, so it's clear where the 3 and the 4 are coming from for you guys. But I don't think it matters that much. I like to be specific. I'd hate to give away points because they're like, oh, what? I needed to see, I wanted to see one or the other. I'm just going to give you both because it's not wrong to put both there. It's just more information than maybe you need, but, I'm going to cross my T's. I'd hate to give away, an easy point on something like that because they're looking for, they needed me acknowledge that I was finding this on H, and then somehow H is also equal to N, so I want to be really specific about which function I was using the IVT kind of on, and then it just follows through because N is just H there.
So you're just proving that n of t is equal to 1,000? Is that pretty much what you're doing?
N of C.
Oh, n of c.
Yeah, I found a C on 3-4 that does that, so that's my specific T, is this C that I pulled using the intermediate values. I know it feels like alphabet soup, but Katie, is that?
Yeah. So you don't even have to use that second.
No, not for this part. I'm assuming that in part C or part A or something you would have used it, but for this part it did not matter. Because everything we were concerned about was from 0 to 10. So the second part of that piecewise meant nothing to me. What does part C say? Yeah, so part C you would have used it. Part C asks for the limit as n of t approaches, or as the limit as t approaches infinity of n of t. So there you would have used part B. And you would have said that it's going to be 87 or 8700 over 3, right? Because it's leading coefficient over leading coefficient. Do you need to reduce that? Never. Never do any reducing on the AP exam. On a free response section, it can only cause you to get the wrong answer.
But you would, so if you're given like ST approaches, oh, it'd only be infinity, because you can't do negative infinity,
Because it's not even defined on, NFT isn't defined on even to negative infinity. Because it only goes from 0 to positive infinity, because t is time.
Yeah.
What the heck would negative time mean? Negative 10 would be like 10 months before the book was published. Well, the sales should be 0, I would hope, because who's buying a book that doesn't exist? I don't know. Maybe there's pre-orders. Maybe you would want to define a function somehow that way.
Okay.
But like, yeah, it could be a question they could ask with how this is defined. Is this feeling okay? Chanel.
So I actually had a question on absolute value functions.
Yeah,
So,
sure.
Could you go to the lesson, because I just wanted to ask a general question about them. It was, I think, 2 points.
Yeah, we talked about this morning, right?
Yeah, but it was another question about it.
Okay,
I have so many.
that's okay. It wasn't 2.5, so it must have been 2.3.
Yeah, probably.
Let's see. Yep, there it is. So I'm just going to grab some of these guys. Is that okay? Sound okay?
Yeah.
Okay.
So my question was like, it pretty much answered it. So in the homework, in the notes, it said like x approaches 0 with an absolute value function, but I was gonna ask, could it approach another number 2?
Sure.
Okay, so could you do like example like 44?
Sure. Okay, so if I try to do direct substitution, what's the problem here?
You're gonna get 0 in the denominator.
And 0 in the numerator, right?
Yeah.
So it's 0 over 0. Okay? So what I'm going to do then is I'm going to observe that the absolute value of x is equal to negative x for x that are negative, and it's positive x for x that are greater than or equal to 0, right?
Okay. Why is it just less than 0, not less than or equal?
It doesn't really matter where you put the or equal to.
Oh, really?
Yeah.
Okay, good.
Yeah, negative of 0 is still 0. 0 of positive still, it's still 0. Like it's just, so it's fine either way. So if I do the limit as x approaches negative 2 of this thing with the absolute value, I'm basically going to split this into 2 limits. I'm going to look at the limit as it approaches from the right and the limit as it approaches from the left. Nope, I said those reverse. I wrote the left one on top and the right one on bottom. So here, if I'm getting a negative value, that's coming in here, right? So I'm going to replace the absolute value of x with negative x. So that just becomes 1, right?
Yeah.
And here, I'm going to it's approaching negative 2 from the right. Oh, I still get the same thing, right? Still negative.
Okay.
So x plus 2. So just 1. So that's what the limit is, 1. What if we did like 42, right? Ms. Nolan, is that what you're gonna,
No, I was gonna ask, why does the limit of -2 come from the left equal 1?
because it's still a negative, why does this one equal 1?
Yeah.
Because if I simplify the top, it's just x plus, or 2 plus x, Over 2 plus x. so it just reduces down to 1. Yeah, if I skate past something and you're like, what? Say something for sure. Let's look at 46. That was the limit as x approaches -6 of 2x plus 12 over absolute value x plus 6. So here, the absolute value of x plus 6 is negative of x plus 6 when x is,
Less than 0?
nope, less than -6, right? Because if I do -6 plus -6, that's what gives me 0, right? Anything less than -6 will be a negative number that we need to make positive.
Oh, so, okay, I get it.
And then it'll just be positive x plus 6 for x greater than 6.
It's pretty much like the value you're avoiding, if that makes sense.
Yeah, I think about like, when do I need to make this positive? Like, what value of x do I need to start making? Do I get negative values?
Wait, so why is it x is greater than 6? And then x is
Oh, sorry, that should be -6.
Okay.
Thank
Like,
you.
There would be no equal sign for this one?
Oh, yeah, sure.
Okay.
It doesn't, and again, it doesn't matter where you put it.
Okay.
Yes.
Okay.
These are all good questions. I forgot all those things. So, yes, absolutely. Like, pick at the details. The details matter.
When it can be,
What's up?
or it can be equal to -6.
Yes, and it doesn't matter which one you make equal to, whether it's the negative or the positive.
Or that equals 0.
Uh-huh. Which is fine, because if you make 0 negative, it's still 0. If you make 0 positive, it's still 0. So it doesn't matter whether you put it with the positive stuff or the negative stuff. It just 0 stays 0.
How do you know when to do this? This like put -6 instead of 0. If that makes sense. Like,
Well, is the absolute value of x plus, or 0 plus 6, it's not the boundary, right? Where it changes between the two pieces. Like, it's because it, like,
yeah.
stays this positive thing.
Okay.
So if we do this now from the left, I have 2x plus 6 over negative x plus 6. Well, that's going to be -2 when I factor and reduce.
Oh, okay.
And then this one from the right, the denominator now is positive x plus 6. So that becomes positive 2 when I reduce it. And because the left-hand limit and the right-hand limit don't agree,
So then it doesn't exist.
this one doesn't exist.
Okay.
And I'd say, like, I wouldn't expect anything harder than that,
Okay.
right? Like, that would be as hard as you'd need to go, or as hard as I would make it. But this trick of having to remember that, with the absolute value, I have to break this into a left-hand and right-hand limit. You can't just direct sub your way through it. Sometimes you might get lucky like the one above and get the right answer, but probably not. Because if you just drop the absolute value on the one above, you don't even get the right answer. You get the wrong answer. Yeah, it's you just have to remember to do that for the absolute value ones.
I thought homework quiz questions like reflective of the test too.
I wouldn't say it's necessarily. I would say that, again, when I wrote this, I was largely looking at the test.
Okay.
Like, when I wrote this, I was looking at the test while I did it.
Oh, okay.
And I picked things that resembled the test. Okay. Now, some of it's like I made a multiple choice question, but if you could do this question from the homework, you could do this multiple choice question.
Okay.
So like, some of the stuff is like well suited to turn into a multiple choice question. Some is not, right? Something like what we just did, I think would make a poor multiple choice question, because like there's a lot of algebra that I would like to see there to assign partial credit for,
Okay.
right?
What does it mean that like know when it's continuous or discontinuous on the test one? Where it says that, yeah, like can demonstrate whether a function continues or discontinuous.
At a specific x.
Yeah, can you show like an example of that?
Sure. So like, let's say that we have like f of x equals x for x less than 1 and x squared for x greater than or equal to 1.
Oh, so you have to graph it.
So is this,
and-
you don't need to graph this. So you can just look, and then we want to know, is f continuous at x equals 1?
Okay.
Or if we could just ask it if it's continuous, period, right? Or we could just ask continuous. So it'll be the same work to do either one.
Okay, so would you just like graph
So
it?
if f is, no, I wouldn't graph anything here.
Oh, really?
Yeah, so I know f is continuous from, or I should say for x less than 1, because f of x is equal to x for x less than 1, and x is a polynomial, right? And I know f is continuous for x greater than 1, because f of x equals x squared for x greater than 1, and x squared is a polynomial.
Polynomial,
Right.
polynomial, continuous.
Well, we have to check out 1 now.
Oh, okay.
At x equals 1, the limit as x approaches from the left of f of x is just the limit as x approaches 1 of x, which is 1. And the limit as x approaches 1 from the right of f of x should be the limit as x approaches 1 of x squared, which is 1. And f of 1 is 1 squared, which is 1. And since the limit as x approaches 1 of f of x equals f of 1, f is continuous at x equals 1.
Wait, so where did you get the f of 1 equal 1 squared from 1? Like,
Because if I wanted to do f of 1, well, 1 should be plugged in here,
yeah, because it's
so it's
cool.
so it's 1 squared.
Okay.
So that's, again, to do, if I want to show just f is broadly continuous, I need to include these 2 additional statements. If I just want to show continuity at 1, I just need this last stuff.
Okay.
But either way, whether I want to show it at 1 or just in general continuous, I need this stuff in orange.
Okay.
Does that feel okay?
Yes. Thank you.
So if I want to show something isn't continuous, I just need to show that, like, this fails,
Okay.
right? So if the limit doesn't exist, it fails. If it doesn't equal, or if f of a doesn't exist, fails. If the left hand and right, or if the limit doesn't equal the thing, it fails. You know, like,
So they have to match the criteria of their domain. That makes sense. Like x is.
so what this is saying, if for this to equal this, so like the limit has to lead into the same spot, and then there has to be a point there.
Oh.
That's what it's saying.
Okay,
So the limit has to lead into the same place, and then there has to be a point there.
Got it.
That's what it's saying. Because if the limit just leads into the same place, but there's not a point there, that's not continuous. Or if there is a point there, but it's not where the limit is, that's not continuous. Or if the limit does this, or the left-hand, right-hand limit that's not continuous. Or if like, you have something like this, that's not continuous, where the like, or I should say this, like, oh, the limit is infinite, but like the function's not defined there.
Yeah.
Right? Like that's not, like, so no matter what kind of discontinuity you draw, that statement will never hold.
Okay.
Right? So that's what it's saying.
Okay.
Does that?
Yes. Thank you.
Sure. You guys feeling any better about like what to expect or like how to do stuff? I'm hoping that at minimum we're like better organizing all these skills we've talked about in your mind. So your toolbox, rather than just like a bunch of stuff dumped in one big bin, it starts to look more like a file cabinet than just like a stack of papers. Or some of us maybe just like a pile of papers. It's not even a stack. It's just like, I got some stuff, reach in and see what I pull out. I don't know, that's a thing I've done before, let's try it. As opposed to like, oh, this problem, I do this. And then put it away. This problem, I do this. Ideally, that's what our brain looks like, is the file cabinet. That's what studying should, like my purpose is as a math student when I'm studying, is I want to build my file cabinet. Now I might be adding some stuff into my files still while I'm studying, but like in general, I want to build out the file cabinet of like, okay, it's not just what do I do, it's when do I do it, right? Like when do I do this skill, and then make sure that it's like filed away under the right, the right heading or whatever. So when I see it on the test, it's like, that's what I do. So I'm not just like, man, do I do this time? I don't know, I do it sometimes. This is sometime. Let me just try it, Like that's how we run out of time, is when we're just trying things. You know what I mean? Yes, Chanel.
I have another general question. So under the study guide, it says know which functions are continuous over their domain. Are you talking about like trigonometric functions?
Yeah.
Polynomial?
Yeah,
Okay.
that's all I'm talking about. Just
Okay.
And it's basically like if you've seen it before, it's continuous over its domain, right? Like it's not a complicated list. It's like all the stuff you did before in pre-calc or algebra 2. Those things are all continuous over their domain.
Perfect.
So it's like it's not complicated,
Okay.
right? And I'm not going to ask you like write down all the things that are continuous over their domain. No, never would ask you to do that. I would just like, you have to be able to look at it and go, okay, this is something that's continuous over its domain, so it's okay for me to direct substitute. Oh, this thing isn't, so I can't direct substitute into this. Like something like that's what you need that for. Or like, oh, I can use it to like be able to tell this function is continuous, so I can use the IVT, right? Like that's what you need that stuff for. It's not, I'm not going to ask you specifically for those things. It's so you can use it to do other things correctly, or to like apply the intermediate value theorem correctly, just for that. But it's important, but it's like, it's not complicated. It's just like all the stuff we've done before continuous over its domain. Doesn't mean it's continuous everywhere, just over its domain. Like 1 over x isn't continuous everywhere, not at 0, but over its domain, like,
Yeah.
right? But if I try to look at the limit as x approaches 0, I can't direct substitute into that because we're not continuous there. Sure.
When you're multiplying by 1 over x squared
Mhm.
or 1 over x squared, do you basically just want to match the highest power?
Yeah, ostensibly, yeah. That's a fair goal. The one place where it could be tricky is like, if I had something like, if I do that, actually, I don't want to do it that way. I want to make it that. What am I going to multiply the top and bottom of this by?
X 1 over X.
Yeah.
The B in the square root.
But I also might think of it as,
Square root of 1 over X squared.
Yeah, that's what I thought.
so I would think about it that way to go into there, that way to go into there, and this way to go to these places.
Before you even multiply all those, could you just like,
If it's a multiple choice question, can you just say this is infinity? Of course.
yeah, but can you also just say that X, it's on the bottom of X squared plus X minus X? Or just
Well, that's not true, though.
you can't just simplify it with.
Well, because, well, you can't simplify like that. You can do this. You can say that, but you can't say the square root of a plus b is equal to the square root of a plus the square root of b, which is what you're trying to do, isn't it?
Yeah, I guess.
Yeah, so think about it this way. If I have like 9 plus 16, that's 25, right? But if I took the square root of 9 and the square root of 16, that's 7. Those aren't equal, right? You can't break a radical at an addition or subtraction symbol. It's just the algebra breaks. Doesn't work. Is that?
Yeah.
And it's tempting to do looking at that. You're like, oh, I want to just. Please don't. Got to be careful there. But you're good?
Yeah.
Okay. Chanel.
So you could say it's infinity. Is it because like X cubed the
Well,
greatest?
the degree here is 3, and the degree here is basically squared, right?
Yeah.
So that's how I know.
So like you can like hypothetically put in like infinity, like even that positive over what's it called?
Well, this thing is like essentially just x squared, right?
Yeah.
So the degree of the numerator is 3, degree of the denominator is 2. So it's going to either positive or negative infinity. This is going to infinity. Everything up here is going to be positive because it's all added.
Yeah.
Here, the bigger thing minus the smaller thing, that would be positive.
Okay.
So positive infinity. Ideally, you could look at it, just if this was a multiple choice question, be like, oh, I know it.
But can't you not subtract by infinity though if you're plugging in?
Right, but you don't want to think about it as infinity. You want to think about it as just big number. So if I have like 10,000 squared minus 10,000, that's still positive,
Oh.
right?
got it.
Because all I'm trying to do is figure out the sign, because I know there's an x on top when I multiply it by the 1 over x squared.
Okay.
So I just need to know if it's going to be like positive infinity or negative infinity.
Okay.
And that's all I'm doing, like positive, positive, positive on top, all positive. On the bottom, I have bigger positive minus smaller positive, still positive, right? So I'm convinced positive infinity. If we're going to negative infinity, I think it would be negative, right? Because the top would be negative number, positive number, negative number, but the negative numbers would be, the first negative number is much bigger than the other positive. So the top should be negative. The bottom would be positive, bigger than, and then minus a negative. So that should be positive. So it'd be negative over positive. So it should be negative infinity on that one. But I'm just kind of checking signs, you know? And again, like plugging infinities in is tempting, but you don't want to get in the habit of that for something if you're trying to figure out what the sign is, the SIGN. Think about like, oh, positive infinity, just like plugging in big number. Like think about 10,000 or something going in there. If it's negative infinity, think small number, think like negative 10,000. Don't try not to think infinity, because sometimes that can give you the wrong intuition there. Like think really small number, really big number. Like use 10,000 as a proxy or whatever. This should give you everything you need, and will avoid the situation like infinity minus infinity, which is what you would see on the bottom, which is not helpful to us in figuring out what the sign should be. You know what I mean? I am pooped today. I did like a lot of teaching today. This is just a lot of talking for TJ today.
Good afternoon.